On my first video, I reviewed the different topics on the Algebra 1 state test that you can solve by just using the state test calculator and showing you some tricks with that. Here I'm going to go over all of the other topics that you can't solve by just using the graphing calculator. So first, a question where they're giving you an equation and there's a mistake in how they solve it. These are often questions where they're giving you a table like this one here, and they're asking you where is the mistake. But then they're also asking you for the solution, and for that part you can use the state test calculator to find the answer to that equation. But when trying to find the mistake, what I recommend is you look at one line at a time. If you compare the first line to the second line, look and see how it changed. What step did they perform to solve that equation? Keep in mind that there are several different paths to solve an equation and get the same answer. So they might choose to do a step that you wouldn't have done yet, and that's fine. That's not a mistake. Look and see what step they performed and whether they did it correctly. So for example, with this one, I notice that the parentheses are gone. They distributed. Did they distribute correctly? Well, if there's a negative sign outside the parentheses, that's like being multiplied by -1. Or you can think of it as just distributing that negative sign. When I distribute -1 to x, I get -x, but -1 times -4 is +4. So the mistake is in step 1. This should have been +4. Then if that asks me then, what is the solution? Then you can solve it using the graphing calculator. Just add a +y to one side of the equation so that you have an equation with x and y, and then graph it. See where it intersects the x-axis. For the second one, again, look at the given line and compare it to the first step. I see the parentheses are gone. Did they distribute correctly? Yes. Now compare the first step to the second step. Well, they moved that 4x over. Did they do that correctly? They moved that +60 over to the right. Did they do it correctly? No. If they subtracted 60 from both sides, then this should have been -60. So the mistake is in step 2. Next, literal equations. These are equations that have a lot of variables. You solve them the same way that you solve a regular equation. You're moving things to the other side of the equal sign by doing the opposite, the inverse operations. So if you look at the first one here, if I want to solve for m, I first am moving what's added to that or subtracted. Always undo what's added or subtracted first. So if I undo this -3n, I'm going to do that by adding 3n on both sides, because -3n plus 3n cancels. On the right side, I have 8 plus 3n, and I can't combine those. Those aren't like terms. So that's what's weird about these literal equations, is you end up with something like 4m equals 8 plus 3n. Now, to get m by itself, I divide to undo that multiplying by 4, because that cancels out, and I'm left with m. And you divide the whole right side by 4 as well. For the second one, if I'm solving for h is being squared and also multiplied by w. So first you undo the multiplying by dividing by w, because w divided by w cancels out. So we're left with this. Then you undo the squaring. The opposite, the inverse of squaring, is square root. So you take the square root of both sides, and that cancels out the square. The next is domain and range. So you need to remember that domain is the x's and range is the y's. So domain is x, range is y. You need to have that memorized. Remember, the x-axis goes left to right. So if you're looking at a graph and they're asking for the domain, they're asking how far does that graph go to the right? How far does it go to the left? Like the x-axis. And the range is the y. The y-axis goes up and down. So how far does our graph go up and down? If you look at this example on the right, we're only seeing one part of the graph. If we continue to zoom out, this graph is going to continue to go up and up forever and also stretch out to the right forever. It's going to go up forever and stretch out to the left forever. But it only goes down to -1 and it curves and goes back up. So now, if I'm asked for the domain, how far does it go to the right? Well, if I keep on zooming out, ultimately it goes forever to the right. It goes forever to the left. So the domain is from -infinity to infinity, or commonly we just say all numbers, all real numbers. The range, how far down does it go? It only goes down to -1. How far up does it go? It goes up forever. So all of my y's are above -1. Y is greater than -1. Or if it's a function, they might say f of x is greater than -1. So domain is x, range is y. Make sure on the multiple choice, they're asking for the domain. You pick the choice that uses an x. They're asking for the range. You pick the choice that uses a y. It doesn't matter if the number's right. Make sure that you're picking the correct variable, x or y also. With writing equations and functions, if you are given a scenario, make sure first off you read it through, see if they are defining what the variables are. They might say h is the number of hours or x is the number of bags of flour. So look at that and see what the variables are defined as. Then think through the scenario. Come up with an example if you need to. Like here, an electrician charges $40 for a visit plus $25 per hour. Think about it. If the electrician was there for 10 hours, how much would I have to pay them? $40 plus 25 times the number of hours, right? 25 times 10. Realize that you know how to do the math. You need to ask yourself, what am I doing? I'm multiplying the $25 times the number of hours. Coming up with those examples helps you to realize which of those numbers is being multiplied by the variable. Sometimes it's a two-part question. The first part is writing the equation. That's part A. The second part is solving. Remember, when you solve an equation, you can use that technique using the graphing calculator. With systems of equations, remember you can easily solve a system of equations using the graphing calculator by graphing both equations and seeing where they intersect. You might be given a question like this that kind of gets around that to see if you know how you can modify equations like you would if you were using the elimination method to solve the system. So remember, with equations, you can modify an equation as long as you do the same thing on both sides of the equal sign. I can add 2 to one side, but I have to add 2 to the other side. I can multiply the left side by 3, but I have to multiply the right side by 3. So this type of question has shown up a few times where they're giving you a set of equations and asking which of these options is going to give you the same answer, the same solution. Basically, which of these sets of equations are the same, but perhaps it's been multiplied by 3 on one side and 3 on the other. The key thing with this is to look at each choice, see how it's changed, and make sure if it's being multiplied by a number that both sides are being multiplied by that same number. So for example, if we look at option A, notice the second equation is the same. That's fine. The first one is different. How did it change? Well, 2x became 4x, so they multiplied by 2. Did they continue to multiply by 2? 3y became 6y. That's good. Multiplied by 2. M became negative 2m. So they multiplied the left side by 2, but the right side they multiplied by negative 2. So this is not an equivalent set of equations. So the answer is not A. If you look at option C, That one is the correct answer. Take a look. Notice that the first equation stays the same. What is happening with the second equation? What are we multiplying by? You're multiplying every single thing by 3. So this second equation is the same, but everything was multiplied by 3. So the answer is C. Correlation coefficient is used when you have a scatter plot to describe the relationship. Correlation coefficient can go from -1 to +1, and the zero's in the middle. If the correlation coefficient is 0, that means there is no correlation. If you were to graph it, the points are all over the place, like this. Where as it gets closer to 1 or -1, the more the points are forming a straight line. Notice that our points are closer to our line of best fit, the closer the correlation gets to either -1 or +1. So as it gets close to 0, the more scattered it is, the weaker the correlation. As it gets closer to 1 or -1, the stronger it is. So just because it's negative doesn't mean it's weak. Just because it's positive doesn't mean it's strong. The closer to 0 it is, the weaker it is. The closer to 1 or -1, the stronger it is. What the positive and negative mean is what is the relationship between those variables. When you graph it, is it positive slope or is it negative slope? That's what determines whether the correlation coefficient is positive or negative, the slope of that line of best fit. So here you have -0.823. That is strong negative. So that's why the answer is that top right graph, strong negative correlation. This is another type of correlation coefficient question. It's asking which of these choices has strong correlation. So again, keep in mind, if the closer it is to 1 or -1, the stronger it is. The closer it is to 0, the weaker, because 0 means no correlation. Negative does not mean weak, positive does not mean strong. With sequences, if you're asked to find the 100th term of a sequence, or in this case, the 80th term of a sequence, what I recommend you do, unless you have the formula memorized, is come up with an example, like 3, 5, 7, 9. If I wanted to find the 100th term of this sequence, I can. Notice that if you know the first number, and you know what we're adding each time, I'm adding 2, I'm adding 2, I'm adding 2, you just have to think about it. How many times did I add 2 to the first number to find this 4th term? I added it 3 times. How many times would I add 2 to that first number to find the 5th term? I would add it 4 times. You're always adding that common difference to that first number, one less than whatever term you're asked to find. So in this case, if I'm asked to find the 80th term, if I know the first term is 52, and I know I'm adding 5 each time, I'm going to try to find what is 52 plus 5 79 times. So I'm trying to find the 80th term. So 1 less than 80 is 79. This is what I put in my calculator, and I'll see it's 447. If you're given an equation to represent a function and you're asked to find, for example, the 9th term, all you do is you substitute 9 into that function for n. So I find out what is 7 times 3 to the 9 minus 1 power. If I put that in my calculator, I can see what the answer is. Because with sequences, the terms are numbered. If you have an equation to represent a sequence, when you put 1 into the equation, it should give you the first term. When you put 2 into that equation, it should give you the second term. When you put 3 into the equation, it should give you the third term, and so on. So if you have a question like this where they give you the sequence and they want to know which of these choices is the equation to represent this sequence, you can just test out each choice. So if I look at choice A, I'm going to put 1 into that function for n and see if it gives me the first term, 24. It didn't. It gave me 16. 24 minus 8 times 1 is 16. So I already know the answer is not A. I'm looking for which of the choices, when I put 1 into the function for n, it gives me that first number in my sequence. When I put 2 into that function for n, it gives me the second number. 3, it gives me the third number, and so on. Which of these functions represents this sequence? Slope and rate of change are the same. Rate of change, if you're given like a word problem, a real world scenario, and they have a graph, the slope of the lines in that graph represent the rate. So if this graph shows Karen's marathon and her time per her hours per mile or miles per hour, that is showing the rate at different hours of her race. So I can look at it and see, when did she take a break? When is her slope 0? It's 0 when it's flat. Think of slope as steepness. So here at C, it's flat. She's taking a break at that time. At E, it's flat. She's taking a break at that time. Her speed, her rate is 0. If I want to know when is her rate the fastest, then I'm looking for the steepest line. Because if the slope is 0 here, the speed is 0, that's pretty small. If it starts to get a little bit steeper, it's getting faster, but the steeper it is, the further away from 0 is, as far as slope goes, the faster the rate. So you can just look at the graph and try to find the steepest line. And notice that it is the blue line here. That is steepest. If you're not sure, you can use the slope formula and find the difference between the y's and divide it by the difference between the x's. That's what I did over here. But often on graphs like this, you can look at it and visually see when the slope is the highest, the steepest. All right. Frequency tables. Let's talk through this question in the top right. They want us to complete this frequency table when they've given us a few pieces of information. It's important to know with frequency tables that rows add up to totals. So these two numbers add to this. And also columns total. So these add up to this total. These add up to this total. These add up to this total. If you know that, once you fill in some of the boxes, you can figure out the rest. So if we look at the information here, it tells us that she surveyed 26 total students. So that number goes in the bottom right. It also tells us that 50% of the students were not in band. So that's half of them. 13 weren't in band. So I put that in the bottom right there too. It tells us 14 total boys were surveyed. So the total for boys goes there in the left. And then it says 2 out of 3 girls are in band. So first, if we know that 14 boys were surveyed, then we can fill in this right here. This must be 12 because 14 plus 12 adds to 26. Now I can use the fact that there's 12 total girls and 2 out of 3 aren't in band. Then I'm just finding what are 2/3 of 12. That's how I figured out the 8. After you fill those out, now you can start filling in all the empty spots. So I knew that if this adds up to 26 and this is 13, then this must be 13. If this is 26 and this is 14, then this must be 12. 14 plus 12 is 26. If this is 12 and this is 8, then this must be 4 because 8 plus 4 is 12. and so on. So you're just kind of looking and figuring out what number goes here if I know that they add up to this. So that is frequency tables. Histograms, it's important to know that each bar represents the number within that interval. So the number here, it's saying songs, people that have 0 to 499 songs, there's one person. People that have 500 to 599 songs, there are 3 of them, and so on. If they ask you a question to interpret this, keep in mind you might need to look at more than one bar. So for example, how many students have more than 1,000 songs? Which bars are we looking at? Well, these people have 1,000 to 1,499, so I need to add them together with these also. These have more than 1,000. These people have more than 1,000. So look and see how many people have those different intervals, a different range of songs, and then add them together to find the total that have more than 1,000 songs. If you're given a set of data and asked to create a histogram, you want to sort the data. Figure out if they gave us a bunch of numbers, you want to make a list of the different intervals and just count how many of these numbers are between 0 and 499. How many of the numbers are giving me are between 500 and 999. That's how tall that bar is going to be. You might be given a question where you're asked to pick the most appropriate unit of measure. Think about the situation. If it's the distance between 2 points, it might be feet or yards or inches or miles. That's the distance you can measure with the ruler or a meter stick. If it is the area of a flat two-dimensional space, like the floor in a room or the wall, you're painting a wall, that is the square units. So it might be square feet, square yards, squared inches. And if it's the volume, liquid poured into a container inside a three-dimensional figure, then you're using cubic units. So think about the situation, whether it's basic units, square units, or cubic units. Here's a review of measures of central tendency. If you want to pause it and read over these different descriptions. And lastly, let's talk about box and whisker plots. So this is a box and whisker plot. It goes from the smallest number to the biggest number. So the numbers might go from 50 to 190. The line in the middle here, this is called the median. The line in the middle of the box is always the median. And then you have your first quartile and your third quartile. Each of these sections contains 25% of the data. So 25% of the numbers are here, 25% of the numbers are here, here, and here. There's 4 sections. And lastly, the measure of the box is your interquartile range. Your middle 50% of the numbers are from here to here. So if it is from 20 to 90, the interquartile range is 70 units. So you can compare box and whisker plots. You can say the girls or the boys, which one has the highest median. So girls is 67, boys is 66. This is saying that the middle 50% of the girls' data is between 66 and 69, where the middle 50% of the boys' data is from 65 to 70. Notice the boys has a bigger range. It goes from 61 all the way to 73, where the girls' heights in inches is from 64 to 70. So you can analyze data in a box and whisker plot. There was a question before where they gave you 2 sets of data in a box and whisker plot, and the other was just some numbers written out. So in order to find the median and the interquartile range, you need to convert it to a box and whisker plot. So let's quickly talk through that step, those steps to do that. Here, if I'm given this set of data, if I want to make a box and whisker plot, you first want to write the numbers from smallest to biggest, and then count inward to find that middle number, the median. The median divides the data set into two parts. There's the numbers smaller than the median and the numbers bigger than the median. The quartile 1 is the middle of those numbers smaller than the median, so that's 3. Quartile 3 is the middle of the numbers bigger than the median, so that's 10. So using the smallest number, the biggest number, the median, and then your two quartiles, you can draw those lines and create your box and whisker plot. You can see what the interquartile range is. It's from 3 to 10. So there's 7 numbers in that interquartile range. And that is that. I know there's a lot of information on this video. It's meant to just be an overall review. The slides I have here are the review sheet that are also posted in my classroom. So make sure that you use that to study and that you do all you can to make sure you're prepared for this test.